Space is big, really big. The Milky Way alone is about 100,000 light years across, and yet it's just one of 2 trillion galaxies we know of. But here's the problem. At our current fastest speed, reaching even the next star system would take tens of thousands of years. So what if there was a cosmic shortcut, a tunnel through space-time that could take us instantly beyond our galaxy? Today, we're diving deep into the science, the theories, and the wild possibilities of wormhole and asking, could humans really use one to leave the Milky Way? What is a wormhole? In the simplest terms, a wormhole is a tunnel connecting two distant points in space-time. Imagine space as a flat sheet of paper. If you fold that sheet so 2 points touch, you could draw a line between them, and boom, you've just made the idea of a wormhole. The concept comes straight from Einstein's equations of general relativity. In 1935, Einstein and physicist Nathan Rosen proposed the Einstein-Rosen Bridge, a mathematical solution that connected black holes and white holes. Now, this was all math on paper. Nobody's actually seen a wormhole, but the equations suggest they could exist. Think of them as cosmic subways, skipping the long trip and jumping instantly to your destination. Types of wormholes. There are several theoretical kinds. Schwarzschild wormholes, the simplest type, but unfortunately unstable. They collapse too quickly for anything to pass through. Traversable wormholes, popular in science fiction. These could, in theory, allow people or spaceships to travel through safely, but to keep them open, you'd need something exotic, literally called exotic matter. Quantum wormholes, tiny subatomic connections that might pop in and out of existence, a kind of cosmic foam at the smallest scales. In science fiction, like Interstellar or Stargate, these wormholes are stable, huge, and ready for adventure. In reality, they'd be delicate, dangerous, and hard to even detect. Exotic matter and energy problems. Here's the catch. Gravity naturally wants to collapse a wormhole. To stop that, you'd need negative energy or exotic matter, something that behaves in ways ordinary matter doesn't. Negative energy isn't just science fiction. It appears in certain quantum effects like the Casimir effect, but we've never been able to harness it in large amounts. And that's the problem. Stabilizing a wormhole big enough for a spaceship might require more energy than our entire sun produces over its lifetime. Could we leave the Milky Way through one? Let's imagine for a second that we do have the technology to make a stable, traversable wormhole. Could we place one end here in our solar system and the other far beyond the Milky Way? In theory, yes. A wormhole doesn't care how far apart the two ends are. The problem is placing that other end. You'd need faster than light travel to bring the second mouth to a distant galaxy in the first place. That's the paradox. To use a wormhole for intergalactic travel, you may already need intergalactic travel to set it up. Wormholes aren't just about distance. They mess with time too. If one mouth moves at near light speed and returns, relativity says time at each end won't match. That means a wormhole could be a time machine. This leads to paradoxes, like the grandfather paradox, where you could change events before they even happen. Some physicists think nature might prevent this by making such wormholes collapse before you can cause trouble. Are they real? Right now, wormholes are entirely theoretical. We've never detected one. But scientists are looking. Some suggest unusual gravitational lensing, where light bends strangely, could hint at a wormhole's presence. Still, even if they exist, they might be microscopic, unstable, or hidden inside black holes where no one can use them. the future of wormhole travel. So can humans leave the Milky Way through a wormhole? Not with today's technology. We can't create them, can't stabilize them, and can't find them. But science advances quickly. A century ago, powered flight was just beginning. A century from now, who knows? Wormholes remain one of the most fascinating possibilities in physics. A dream of cosmic shortcuts that could take us to distant galaxies, alien civilizations, and maybe even new universes. Until then, we'll keep looking up, keep asking questions, and keep imagining, because imagination is the first step toward discovery.